Good afternoon, good evening, depending on when you're watching this. It's your boy, Mr. Malaji, and I'm excited to do this next video with you, which is called Trig Identities. So this is my favorite section in Trig. Yep, yeah, it is. And it's just us proving that these identities are in fact correct. So let me first give you the first two identities that we're going to use and apply throughout these proofs. So the first one is that tan theta is equal to sine theta divided by cos theta. So that's an identity that you need to remember. It's gonna definitely be in your formula sheet, but it's an identity that we're not gonna prove. There is a proof in your textbook you can check out, but we're gonna just be using it and applying it throughout us proving these types of identities. The next one is that cos, actually let me put it this way, sine squared theta plus cos squared theta is equal to a 1. So again, this is another identity that we're going to be using. And yeah, we're going to just, throughout us solving these, we're going to substitute either whenever we see sine squared plus cos squared, we're going to substitute a 1. Or whenever we see a 1, we're going to substitute sine squared plus cos squared. Whenever we see a 10, we can substitute this fraction in its place. Or whenever we see this fraction, we can therefore substitute what it's equal to, which is 10 theta. So these are the identities that we're going to be applying. So what do I mean that we're going to be proving these identities? So proof is we're going to have an expression on the right hand side and we're going to have an expression on the left hand side. And what we need to do is we need to take one of the sides, either the left hand side or the right hand side, and we need to simplify it so much so that it's actually equal to the right hand side, right? So that's the idea here. We're taking one of the sides, either the left hand side or the right hand side, and we're simplifying it, right? We are manipulating the equation or the expression. We are substituting these identities and we're trying to make sure that it actually is equal to the right hand side. And once it is equal to the right hand side, then we can conclude that yes, we have proven this identity, and so yes, it is true, right? So let me give you an example of how these would look like. Let's take this first simple one where we are given 1 over cos squared theta minus a 1 is equal to a tan squared theta. That's the identity that we're given them. So how do we prove this? So first of all, I'm gonna take the left hand side. You just choose one side, guys. It's much easier for me to work with the left hand side because that I can simplify. The right hand side seems like there's really nothing I can do that side besides substitute the identity. So let me take the right hand side. The left hand side, and what I'm going to do is I'm going to rewrite it cos squared theta minus 1, and then I'm just going to work with this side, and what I'm trying to get it to look like is equal to 10 squared. So let's simplify this. So with this I have a fraction that is subtracting a number, so what I'm going to do is I'm going to do LCD. So if I do LCD, I have 1 over cos squared theta minus the 1. I can represent it by just timesing it with the cos squared theta at the top and at the bottom. That way I have a cos squared theta divided by a cos squared theta. That is still a 1. The same thing dividing the same thing. It is still a 1. And so we can simplify this, right? Now we have the same denominator. I can add and subtract them. So now I'll put them all under the same denominator, which is cos squared theta. And now I have a 1 that is subtracting a cos squared theta. And one thing I forgot to mention at the beginning of this lesson is that this identity here can also be used in different forms. So this is the original one, but what you could do is you could take the sine to the other side and it would read, or actually let's take the cos first. It would read sine squared theta is equal to 1 minus cos squared theta. Still the same identity. Or we could take the sine to the other side and we'll read cos squared theta is equal to 1 minus sine squared theta. It is still the same identity, just written in different ways. So that's the guy we're going to be using right here. Here at the top, I noticed I have a 1 minus cos squared theta, and that's this guy right here. And that guy is equal to a sine squared theta. So I can substitute the sine squared theta there. So I have a sine squared theta divided by a cos squared theta. So now that I have it like that, I remember that, this guy is just a sine theta divided by a cos theta all squared like that. And that I then substitute the first identity that I know, which is this guy here. That fraction is just equal to 10. So this is essentially 10 squared theta, and this is equal to the right hand side. And there we go. We've proven this identity. So proven or proved. And there we go. So that's how you go about doing these. I hope you guys can see what I did. I just took one side, the left hand side, and I simplified that side until it was equal to the right hand side, which was 10 squared theta. And once it is equal to the right hand side, you just write equal to right hand side and write proven there. So that's how you go about solving these identities. Let's take another one. Let's take one that looks like this. All right, the second question says tan theta plus cos theta divided by 1 plus sine theta is equal to 1 over cos theta. So you're looking at this and you're like, Mr. Malachi, how are we going to ever get 1 over cos theta from just that left hand side? Let's take it and let's work with it. So left hand side, the first thing I notice is that I have a tan theta. Perhaps substituting a sine theta over cos theta would help me there. So let's do that first. I'm going to first write the question, how it looked in the left hand side first. So with these, you don't use equal to signs because the equal to sign will be right there at the bottom. So here I notice that this is just a sine theta using my identity over a cos theta that is adding a cos theta over a 1 plus sine theta. Then once I have this, I have two fractions and I'm trying to add those two fractions. So what I want to remind you is if we have a 1 over 2 plus a 1 over 3. A good way of doing this very quickly is you could put them both under the denominator of 2 times 3. And what you will do is the 2 will times that side, giving me a 2 this side. The 3 will times this side, giving me a 3 this side. And then you just add them in the middle. That's the quickest way I do it. So yeah, that's the law I'm going to be applying here of fractions. So let's apply it. So what I'm going to do is I'm going to put these all under the denominator of cos theta with the 1 plus sine theta. They are multiplying, right? That's why I'm using brackets. Then this denominator will times with this numerator. And so sine theta will times the 1 plus sine theta, right? And then this denominator will times with that numerator there. And so I will have a cos squared theta on that side. I hope you guys are seeing what that is looking like. Then once I have this, I'm gonna distribute this sine theta inside there. And let's do that. So once I distribute it, I have a sine theta plus a sine squared theta, because sine theta times 1 is a sine theta. Sine theta times a sine theta is a sine squared theta. And then we have a cos squared theta there. All of this divided by a cos theta with a 1 plus a sine theta. Right? We're still simplifying. We still haven't gotten the right hand side. Then what I notice is that, ooh, this guy here is an identity as well. It is equal to a 1. It is that second identity that we know. So let's substitute that. Then we end up having a sine theta plus a 1 in the numerator. And in the denominator, it's a cos theta, 1 plus a sine theta. Then we should notice that this guy here, sine theta plus 1, is the same as 1 plus sine theta. Yes, they're the other way around. It's just like having a 1 plus a 2 and a 2 plus a 1. These guys are equal to each other. So what I can do is, since the bottom guy is multiplying, I can cancel them. So I cancel this guy with this guy. Could only cancel because the bottom is multiplying. So what I end up with is I end up with a 1 over a cos theta, and this is equal to the right hand side. And then there we go. This is proven. Right? If you just go up, just to remind you, this was on the right hand side. 1 over cos theta. There we go. So that is number 2. Let us do two more. I want to show you one that has some factorization in there. Alright, so in number 3, we're given this big expression on the left hand side, which is 1 minus cos squared theta divided by a cos squared theta plus a 2 cos plus a 1, and we're supposed to prove that it's actually equal to this small little fraction that we have on the right hand side. So again, how do you decide which side to work with? You always take the one that is most complicated, or the one that you can manipulate. So I noticed that I can manipulate my left hand side. Can't really do anything with my right hand side. Sometimes though, sometimes you might need to manipulate the right hand side and the left hand side. But in this case, we just need to do one of the sides. So let me do the left hand side. So at the top there, we have a 1 minus a cos squared theta. At the bottom, we have a cos squared theta plus a 2 cos theta plus a 1. So in this, before I wrote this, I said this will include some factorization. So what I want you to see is that this guy here is actually a difference of 2 squares. It is a 1, which is a square, that is subtracting a cos squared theta, which is also a square. So we call that a difference of 2 squares. The guy here at the bottom is a trinomial. Right? Maybe the best way that you can actually see that as a trinomial is, let's take that cos is k. Let's take that some cos theta is equal to a k. And I just want you to see it. So it will be a k squared plus a 2k plus a 1. So this is clearly a trinomial. And how you factorize this trinomial is you just look for factors of 1 that add to give you a 2, which will just be a plus 1 and a k plus 1. So that's how you factorize that trinomial. So let's now apply this logic that we have here onto this actual question. So the difference of 2 squares, you should be able to factorize that as well. 2 brackets, square root the first guy, you get a 1. You put that 1 in the first position of both brackets. You square root the second guy, you get a cos. You put a cos in the second position of both brackets. 1 is positive and 1 is negative. That's how you do difference of two squares. Then at the bottom, we've already factorized that trinomial. We said it will just be a k plus a 1. So in this case, it will be a cos theta plus a 1. And it will be a k plus a 1, which is a cos theta plus a 1. Remember, I said k is equal to a cos. So if I substitute the cos back in, that's how it looks like. Then at this point, I notice that actually there's a bracket that is the same. This bracket is the same as this bracket. Remember, I said those things are the same. It's just like a 1 plus a 2 is the same as a 2 plus a 1. So those cancel, and what we are left with is we are left with a 1 minus cos theta that is divided by, actually I can just rearrange that guy, a 1 plus a cos theta. This bracket here, I just rewrote it as a 1 plus a cos theta. And then therefore, this is therefore equal to the right hand side. Let's just scroll back up to confirm. Yes, it is. 1 minus cos theta and 1 plus cos theta. And this is proven. All right. So let's do one more of these type of trig identities, and then we're going to call it a day. All right. So this is question number 4. We're given this trig identity here. Again, we do need to work with the left-hand side. It is quite easy to simplify the left-hand side. So let's take the left-hand side. We have those two fractions that are adding each other. So let's just rewrite it again. 1 minus cos theta plus 1 over 1 plus cos theta. Do not use equal to signs, guys. We're only going to put an equal to sign right there at the end. So what I'm going to do here is I'm going to use the same logic that I explained earlier on, that if I have a 1 over 2 that is adding a 1 over 3, I could just put them all under 2 times 3, and the 2 would times that numerator there, giving me a 2 there, and the 3 would times this numerator this side, giving me a 3 there, and the plus would be in the middle. The same logic is happening here. So I'm going to put them all under the denominator of 1 minus cos theta with the 1 plus a cos theta, right? And then I'm going to times, this guy will times across there, this guy will times across here. So a 1 times the denominator will just give me that denominator, which is a cos theta, and 1 minus cos theta times a 1 will just give me that 1 minus a cos theta. So this is what I have right now. Then I notice that this cos thetas are like terms. They cancel. Cos theta minus a cos theta, they cancel. Then I'm left with the 1 that is adding a 1, which will give me a 2 at the top. Then at the bottom, what I have there is I have that gives me a difference of two squares. Actually, it's a difference of two squares that is simplified, that is factorized actually. So one way to think about it is 1 minus k and a 1 plus a k. If you multiply these out, you always get a 1 minus a k squared, right? You should remember that from your grade 10. So that's exactly what I'm going to get at the bottom. I'll get a 1 minus a cos squared theta. Then what do I know? 1 minus a cos squared theta, using my identities, I know that that is actually equal to this. I'm using this identity here that says sine squared theta plus cos squared theta is actually equal to 1. And once I take this cos squared theta, so sine squared theta is equal to a 1 minus a cos squared theta. So that's the identity I'll be applying here. So this will be a 2 divided by a sine squared theta, and this is actually equal to the right hand side. And there we go. This is proven. So these examples that I've done here, they are very rudimentary, they're very easy, they're very digestible. You can totally work with them and understand them. but in some video in the future I will do test and exams type questions, and in there we're going to be unpacking these difficult questions where yeah, the identity looks so big and we have to prove that it's equal to the right hand side. So thank you so much for tuning in. I will see you on the next video. On that note, bye.